Okay, a mason chisels a sculpture from a piece of rock. The shape of a sculpture is moulded by rotating the curve y squared plus the square root of x equals a cube root of x. Sketch to the right. From the x-axis from 0 to 1, where each unit on the axis corresponds to 1 metre. Use integration to estimate the volume of the sculpture up to 3 significant figures. Okay, so a fairly nice question, to be honest with you. Cube root of x, because we're going around the x-axis, which is this way, we need to make y the subject. So first of all, I'm going to have to bring my x over. So the cube root of x minus x squared. And I know it seems silly, but I always like to make it properly the subject by square rooting both sides. And I know it doesn't really matter because I want to square them and times it by pi. I just like doing it. So because it's a revolution, I have to square it and times it by pi. So when I square this, the square root actually disappears. It just gives me the cube root of x minus x. I want to bring my pi over. I don't like the way this is written because I can't do the cube root when I integrate, so it's going to be x to the power of a third minus x to the power of a half. Okay, and I'm going to integrate this, and my values, if you look at this graph, this was 1, this was 0, so from 1 to 0. So when I add 1 to 3, this will make it 3 to 4. 4 thirds, so when I divide it, this is 3 quarters minus x, and when you add 1 to a half, it makes it 3 halves, so it makes that 2 thirds. Bosh, bosh. I'll need this to the values of 1 and 0. Again, because my second bit is 0, I'm not actually going to do anything with that. I'm just going to focus on the first bit, which actually just gives me 3 quarters minus 2 thirds. Because when I substitute 1, I get the values, and I'm going to use my calculator because I don't trust my fraction skills at the moment. What is it? It's 3 quarters minus 2 thirds, which equals 1/12 pi. Let me just double check the question doesn't ask me significant figures or anything like that. Oh, it does, it says 3 significant figures. Days, I've already deleted it from my calculator, which is nice. So it's 1/12 times pi, which is 0.2617. 1, 2, 3, the 1 keeps it the same. Oh, sorry, the 2 keeps it the same, so 0.261. Okay, the second part says a stonemason carves a sculpture from a conical piece of rock with a radius of 0.5 and a height of 1.5. Work out how much rock the stonemason carves away. Now, you've got to think about your gradient, but then I thought I don't need to. I just have to think about the stone, which sort of looks like that. Okay, a radius of 0.5 is this, and my height is 1.5. And you've got to think back to your GCSE, which is my base, which is pi r squared times by height divided by a third. So the calculation I do is a third times pi times 0.5 squared times 1.5. And it'll give me the whole volume of this entire cone. So it was a third times pi times 0.5 squared, squared times 1.5, which gives me 1/8 pi. Okay, but then we obviously, this is the whole cone, we want to subtract it by the previous answer, which was 1/12 pi. So 1/8 pi, take away 1/12 pi, 12 pi. So 1/8 pi, take away 1/12, no, 1/12 pi, which equals 1/24 pi. It wasn't specific in the question, but it did say 3 significant figures earlier, so I'm just going to continue that trend, just in case. 1, 2, 3, so 0.131. Okay, my last part of the question is suggest a limitation for using this model to estimate these volumes. I'm going to say that when I rotate it, that's going to make it a perfect rotation. However, when it's a stonemason, he's probably going to do little nicks here and there, which is probably going to limit the volume or add a little bit more.